Hello everyone, this is Geo Kedarishwar Kiran from Institute of Aeronautical Engineering, Department of Electrical and Electronics. Today the topic we are going to present, I am going to present is about multiple vehicle formation control based on robotic adaptive control algorithm. The main perspective of this topic is about the formation of the vehicle on the control based robotic adaptive algorithm control. Coming to the algorithm control, in the further slides we will see about this formation of control based robotic adaptive control. Multiple vehicle formation control, a robust robotic adaptive approach. This in general, this presentation explores the development and application of a robust adaptive control algorithm for achieving precious and reliable multiple vehicles formation and control. The vehicle formation and the control is designed innerly in the vehicle system enhancement with control system process of algorithms and achieving the different multi-purpose vehicle formation controls. Now the problem and the statement: challenging in multi-vehicle formation control, dynamic disturbances, communication constraints and system unconstraints. Some of them help for communication constraints and system uncertainties. These constraints and the uncertainties disturbance the dynamic disturbances come under the dynamic disturbances. Unpredictable factors like wind, gust, dust conditions, or varying vehicle loads can significantly impact formation stability and accuracy. Communication constraints, limited communication bandwidth, and potential signal interface can hidden real-time information exchange between vehicles, affecting coordination. In this communication constraints, these are the limiting communication bandwidth with a potential signal and the reference can in the real-time information exchange between these vehicles affecting the system uncertainties. Variations in vehicle parameters, sensors, noise, and imperfect model represent the relation representations of introduce significant uncertainty in the system, posing challenge and accurate control. The main accuracy is about the control, and this system challenging is also an uncertainty representation of the imperfect model of vehicle communication uncertainty system. Fundamentals of formation control strategies: leader follower. The designed leader vehicle guides the information while other maintain predefined relative distance and heading. Virtual structure. Vehicles are treated as points in the virtual structure. They moves on the desired formation. Each vehicle tracks correspondingly point in the virtual structure. Behavior control. Vehicle interacts to their surroundings and other vehicles using pre-programmed rules, artificial intelligence, and maintain formation. In the right side figure, we can see the vehicles are having equal distance and control over the system deprecated and the banned with each of the system track correspondingly point with the virtual structures. Now analyzing of robust adaptive control methods. These adaptive control methods are of three types: robustness, the ability to of the control system to maintain stability for performance in the presence of disturbance of uncertainties. The main process of this control method of adaptive vehicle system is to maintain the ability furtherly for stable performance in the presence of disturbance. Adaptively, the compatibility of the control system to learn and adjust its parameters online to compensate for changing conditions. These are also a type of adjustment parameters of the changing conditions of vehicle control systems. The last one is adaptive control algorithms. Utilize system identification techniques to estimate unknown parameter and update control gains online. These are the different types and methods of controlling the Analysis of the adaptive control methods. In further slides, let us know what is vehicle dynamic modeling and system architect. On the right side of the picture, we can see that there is an steering, a rotor, some different parts like brakes, sensors, steering, lenience, lens. These all are undercome under sensor of the fusion vehicles, GPS and other styling techniques, and for the further enhancement of the steering. Now coming to the vehicle model, a mathematical representation of the vehicle dynamic behavior, including longitudinal and lateral motion. Sensor fusion, combining data for various sensors, GPS, IMU cameras to provide comprehensive understanding of the vehicle state. These cameras and GPS is provided in the vehicles for adaptive model of vehicles to understand the vehicle's current position and the state. The control architect, designing the communication structure and information follow between vehicles, ensuring effective coordination. Now coming to implementation of the control algorithm. Firstly, Archer server. The server receives all the feedback signals and differentiate estimation, dynamation, control signal, and conflictuate the data irings. Implementation of this proposed control algorithm is data acquisitions and parameters estimations, control signal generation, output actuators. Now coming to the data acquisitions, gathering real-time information for sensor about vehicle state, formation, geometry, and environmental conditions. Parameter estimations, utilizing adaptive control techniques to estimate unknown parameter, including these vehicle dynamic disturbances. For the following dynamic disturbances, the vehicle is enhanced in a control signal generation, calculating the optimal controls of input vehicle based on the estimated parameter formation goals, and the output accuracy is about the transmitting the signal to the vehicle actuators, and the steering brakes execute this desired motion. So these all come under the implementation proposed for an algorithm, control algorithm. Furtherly, the parameter estimation and the data acquisition, control signal generation, output, and the actuators are fixed in the vehicle designing of the vehicle. These implementation of control algorithms may helpful for further future generation and uh, for learning or implementing the adaptive skills of these algorithms. Now coming to the simulation and result at the performance analysis. The left side we can see the time solent graph and formation graph. 95% of accuracy formation. The algorithm successfully achieved formation accuracy within a specified tolerance level. Simulation result with performance analysis about the stability is 98%. Stability is about to 98% to form the remain stable under various disturbances and uncertain conditions, demonstrating robustness. 100%, it is 100% adaptively. The algorithm successfully adapted to change in system parameters and disturbances, maintaining this performance. It is 100% adaptive and there is no problem with the system, and enhanced car features with artificial intelligence and other some algorithms of system parameters. Now let us come for a final result that these variable system and modeling of different types of algorithms in the car control system is very much beneficial, and it is advantage for the user or customers who buy it, and the formation and the accuracy, stability, adaptive, it is more than 95% in these three cases. Now coming to the future conclusion and research directions, the proposed of adaptive control algorithm provides a significant enhancement advancement in multi-vehicle formation control by addressing dynamic disturbances. Communication consists of the system uncertainties, future research directions. So the future is about the vehicle enhancement and the research directions control algorithms, communicating the system, exploring and the control architect of scalability, and extending the approach to more complex formations and environments. These environments may or may not be beneficial for extending the future research directions. Anyhow, the artificial intelligence is more in existence in future enhancement. These research directions may be helpful for the multiple vehicle formation control by addressing dynamic disturbances, communication, and the system uncertainties. Future research directions include exploring and control architect of scalability with extending approach to more complex formations and the environments. Thank you.